So service routing is, of course, very interesting topic, right? Because this is how we are going to connect the different applications within the cluster, and then how it is going to go outside, the traffic from outside to inside, and similarly inside to outside as well. Right? So all of these things are required. So I assume that you know that what is east-west traffic and north-south traffic. So north-south typically means that what traffic is coming from the external clients, and east-west you can think of what is happening within your pods. So that is how it is. Um, then there was a point here, which is service provides a way to treat the set of pods as a single unit or a network service. So I think this part is very clear that we kind of combined multiple pods together and then put them under a single name so that the communication becomes easier. Um, Now, I assume that you know that why this is happening there, right? Because your pods would have the IPs, right? And of course, these pods are ephemeral also, right? So even if you use the pod's IP or if you can get its DNS name, but if the pods go away, then it's difficult to again connect back to them, right? That is why we have a service layer, and service layer we fix the name, and then of course the endpoints which we have as pods can come on the go. So for the consumer, right, it's a service name to which consumer connect to, and then the pods can come and go there. So that is how it is. Then the next point comes is once you create these services, we need some way of managing or discover them, right? So how to discover them, that I think talked about later, with the help of DNS and other ways are there by which we can do that. Then the briefly talked about the ingress, which kind of allows the traffic to come from external to internal. So again, we'll jump into further later. And the service mesh, it can be used both for the internal communication, and some of the service mesh allows the north-south traffic as well. That is what is being mentioned. And then the benefit of service mesh, I think, are there is we can have advanced routing, security, observability features. That's how service mesh can help us in a way. Any points you guys want to mention here? Okay, so this, yeah,
Yeah, I think that's pretty clear.
yeah, okay. So that's again we I think discussed. I mean, you would know already, right? That there are these pods, and then we have the service layer, and so the client pod or it can be external. So whenever the traffic comes, the traffic would come to the service layer, and service layer would help us to connect to the pods there. So that is what is being showed here. And then the point here to mention is the service does the load balancing at the L3 and L4 level. So that is one thing which can consider. That's doing the load balancing at L3 and L4 level. So then the next point which I discussed is talked about, I mean, which I was not kind of highlighted earlier for myself is like the way we can assign the pod CIDR, like the way which we saw in the previous chapter, that we can assign a range to the pods what we are having. Similarly, we can have the IP range for the service IP as well. So we can take a range for the IPs, for the cluster IPs, and all of the IPs for service would come from that. And the CNI does not play a role, I believe here. It is handled by the API server. That is what we mentioned here. That API server would handle the IPAM for the services rather than the CNI what we have. Now, there is a way by which you can also hard code the IP address of a service if there is a need, but as mentioned, it's kind of anti pattern. We should not uh, kind of fix the IP address for a given service, it should come automatically. But if you are doing it, it's like you should know that it's not something which you have to be doing it. You should be doing that. And why is that? Because we would have some kind of service discovery mechanism like DNS, through which we can always get the IP address of the service. So that is what is there. Okay. So I think this is pretty much clear. Now here is the service kind here. We can have the selector here, and the way we connect the pods, I believe you would be using Kubernetes, so you would be knowing it already, that our pods are going to have, if any pods are going to have the similar label, they'll connect to it. Yeah. So that's something which is mentioned. So I think, I assume that you know that, right? That when we create pods, for those pods, you're going to assign certain labels. And for all the pods which have this label, they'll become the endpoint to it, right? Now, there's a question here is, can one service point to the pods of different deployments? Yes or no?
If managed by a label, then yes.
If managed by, come again?
If well, the idea here we have the label, right? So
Yeah.
service, so we just provide the label that the deployment has, then yes, then it
Yeah,
should be
correct.
able.
Correct. So that is how it is. So if we have different deployments, and in the different deployments, if the pods have the same label, or whatever the label we are selecting on the service level, so yeah, so the pods can, from different deployments, can be part of a one service. Correct. That is very much clear. Um, so that is there, and then at this protocol level, it can support TCP, UDP, and SCTE protocol for the service layer as well. Right. So there are few different kind of services we have: cluster IP, node port, and then we have the load balancer type. So now, like in this case, we can see that we have a service B, whatever is mentioned here. And then it can point to the, okay, so it's kind of the, they are saying that pod A want to communicate to pod B. So rather than pod A talk to the pod B directly, it would go to the service layer, and from service layer it will go to the pods eventually. That is how the communication should happen. We should not connect to the pods IP directly. We should go via the service layer. That was the point mentioned here. Um, So cluster IP means there is an IP which is available to a service, but it is routable within the cluster only. You cannot have the cluster IP publicly available. Correct. That is what is here. Um, so that is very clear. I had one point to mention. Okay, I think I could not recall that. The next is a type of node port in which we are kind of blocking one port on all the machines, whatever the nodes we have. And when the traffic comes to the given node on a given port number, it would be forwarded to the underlying pods or to the service. So basically, we are mapping um, one node port like 33857 on all the machines. And whenever the traffic comes on any of the machines, the traffic would go to the respective service, and then from the service go to the respective pods there. That is how the communication is there. Now, there are drawbacks of having the service as of type node port. The primary challenge is, as you know that, right, we need to access via the port number. So we would hit the node's IP and the port number. Then what's going to happen is, our clients need to remember the IP and the port number, which is not basically advisable, right? Because nobody wants to remember the IP and the port number. We should give a DNS name. So if you use the service of type node port, we cannot give a DNS name directly. What can happen is you can create one more instance like a proxy, and via that you can map it. So that is how you would do. Um, so have you done something like this earlier, that you are accessing um, the the applications via the node port and giving a DNS name to it via some proxy? Anyone has done that?
Yeah, I have. I mean, I done that in labs, but for example, I'm running a Rancher just for my development purposes on a
Mm,
server from the a server cheap that I pay
mm,
$53, and sometimes I need to deploy a database, for example, in a
mm,
cluster. Because I don't want to stand up instance or stand up containers on my computer, it gets hard. So
mhm,
I might run the database in the cluster and connect to that and expose it on a node port service
mm.
for that.
Right. Yeah. So primarily, anybody else want to comment?
No, I guess similar use case, right? But in my case, it was not a database, just a service that was supposed to be made available on an EC2 VM
Mm,
because they had a hybrid setup. So
mm,
we had two options, right? Either we go with a internal load balancer
mhm,
or we expose it via node port.
mhm,
And it kind of made sense to go with node port because the service was not super critical and that ELB would add to more cost and stuff like that.
mhm.
So we just went ahead and exposed as a node port and kind of accessed it. It was not the same VPC. We had to do peering as well. It was a
Okay.
separate VPC, but yeah, I mean again, it's an internal service that another component has to access, but that other component is not inside the cluster.
Okay. Okay. Fine. Yeah. So if you have to do it right, what software would have chosen? What software would have chosen? Like for example, what I'm saying is so let's say you are on a data center, which is private data center of yours, where you don't have support of load balancers, correct? So if you have to choose to configure like this, which particular proxy you would choose in the front of the nodes?
Which proxy to choose to route like route
So
your traffic?
assuming that, right, you have two nodes available to you from your provider, or you are running in your data center somewhere, correct?
Hmm.
Which does not support load balancer, correct?
Yes.
So what you will be doing is you deploy cluster, you deploy our applications, and then you got the node port, correct?
You can use Nginx for that. Yeah, sorry.
Correct,
Nginx
correct, yeah, correct.
reverse proxy.
Yes. So
That's
basically, what we are saying is we'll configure one more instance here, a VM
yeah.
maybe, and that can work as a reverse proxy. Correct. Yes.
That's how actually the Nginx controller works when you deploy it.
Yeah. Yeah,
It's
correct.
basically with
There
that
are.
purpose.
Yeah. That's true. That's true. Correct. Yep. Okay. Fine. So then that's there, and then we have a service of type load balancer. And with this service type of load balancers, we are um, trying to connect to our cloud providers load balance service. So, for example, here we are on a cloud, and then we would somehow connect to our load balance services, and that load balancer would give us a load balancer on the fly through which we can connect our application for the outside world. So typically for all the cloud providers, AWS, Azure, Google Cloud, there is a built-in um, connector on our Kubernetes cluster through which we can connect to the underlying cloud provider and request for a load balancer. Otherwise, we can also install our third-party load connector kind of a thing, and that can request load balancer on the fly. Um, so anybody has done something like this where you are deploying, let's say, in your data center privately, and you want to have a support of type load balancer? Has anybody done something like that?
You mean in a private data center and they're using load balancer inside the cloud?
No, no, no. Cloud, so load balancer service available within your data center itself, right? So we can,
Okay.
like the way, yeah, that's what I'm
Oh,
saying.
you mean like maybe private cluster, like having a private cluster and a public load balancer?
No, even public privately also we can have, right? So
Yeah,
basically within your local network, right, you can configure a
right.
provider which can give load balancers, correct?
Yeah, you can provide if you, for example, in AWS, you can configure the load balancer with load balancer service provision.
Correct. So
Yeah.
what I'm saying is similarly, you can do local as well, right?
Local.
So
Okay.
because you suppose you manage your own data center completely, right? Then you
Uh-huh.
can give a range of IP address which can behave like a load balancer. Correct. So
Okay.
how would you manage that? Have you done something like this?
No, no, I haven't. Interesting.
Anyone has done it? Okay. So I believe all of you heard about HA proxy, correct?
Yep, I
So
did.
HA proxy can be configured like that. So I mean, of course, there is some addition. I mean, configuration is required, but what we can do is we can give it a set of IP addresses to it, and then we can request a type load balancer from a Kubernetes cluster, which connect to our HA proxy offerings, and then give you one load balancer within the network what you have. So within your private data center, we can also configure like that. So I have seen that, not myself, but at one of my clients' environment, they have done like that. So they configure HA proxy to host set of IP addresses, and then when the request come for the load balancer, it'll take from that particular bucket and assign it. So it's a very interesting use case. So of course, you need to write your own uh, custom CRD, which can map that load balancer request, and based on that, will work. Make sense?
Yeah, that's interesting. I haven't heard of that. That you can do that,
Okay.
but useful to know.
hmm Cool. Okay, so that was the point here. And if you, for example, if you have some public IPs available with you, we can also use Metal LB kind of solution as well. That can also give us the service of type load balancer. So, of course, what I mentioned, that's one way of doing things. Then, if you are, so the one of the use case which I had actually is there my client's cloud provider did not support load balancer type, but they can give us public IP addresses, whatever we would wish. And that is when the Metal LB can come handy. That you have the you have number of nodes available and the public IP addresses, and then basically with the Metal LB we can assign load balancer to our services, and then that way we can manage it. So that's one way of doing things. So there they mentioned two modes you can use. One is the BGP mode, and second one in the layer 2 mode. So I have not used the BGP based, but it's there. It's possible there. Um,
And this use case is only possible with this Metal LB, right? Where you want to bring your IP,
no, come
as
again
you
with your
mentioned.
question.
As you mentioned that we can bring our IPs, right? They don't
Yes,
have a
correct.
load balancer, and this is only like, for example, solution Metal LB is uh, to enable this use case where you can bring your own IP to the load balancer, or there are,
Your
for
on IP
example,
means that, yeah, basically, see, the problem here is again the same way that you don't support the type load balancer at all. So when we say I want to create a service of type load balancer, and you don't
yes,
have somebody who can serve it, correct?
yes,
Then how do you
understand.
do that? So that is when what I was saying, that a use case that at my customer's environment, they could give me the public IP addresses, but they could not give me support of load balancer from the cloud provider.
Yes.
So again,
Uh,
yeah, go ahead.
what I want to clarify, sorry, this can I do that with the other like cloud provider load balancer, bring my own IP, or this is the only solution that I can do this with? If I, for example, I'm in AWS and
Mm.
I can provision load balancer, but I want to bring my own IP instead of using the one in the cloud.
Um, I think if you can reserve the IP address somehow, you can use it. I believe, right? So I
No,
don't.
that's what I'm not sure. That's what I'm asking because uh, This enables that, but I'm not sure if the cloud load balancer will does that. That's why I'm asking if you
See again,
know.
yeah, again the use case there is again it's an anti-pattern kind of a thing, right? Why do you
Mhm.
care about the IP address of your load balancer? You should be managing by the name, right?
Right.
So as long as you can map the name, we should be fine.
Yeah, but I think I remember like a while ago, I was on a project had a use case where we were in Azure, and
Mhm.
they want us to provision the load balancer, but they want to give us their IP address
Mhm.
on internal network.
Of
Uh,
the internal one on the Azure.
yeah, for
Internal one.
so use the Azure load balancer, but give that use the internal IP range for IP or IP. I don't remember. It was a while ago. So, but something of that sort, and I didn't remember if we had a solution for that at the time.
So, when you say internal, is it something like internal, like network? Like, do you have a private network within Azure?
Yeah,
Okay, okay.
something like that. It was 2 years ago. I maybe not recall, but I remember that I was like kind of surprised by the use case that they want us to provision the. At that time, it was an OpenShift, provision an OpenShift with a load balancer, and then change
Hmm.
the and then they change the IP to the one that they want to provide.
Hmm.
So that was kind of interesting.
Okay. Yeah, I'm not sure how do you solve that, but that's what I know that you can. I mean, if you have, I mean, we can search on a bit that we can fix an IP address for our load balancer. There should be a way of doing it for sure.
Yeah, so we also
Mhm.
had this use case. Now, ideally, for most of the customers, yeah, I mean, DNS-based load balancer should work fine, right? But we
Hmm.
had this fintech which required some IP listing for every request incoming as well as outgoing.
Hmm.
And in that case, these ELBs and ALBs kind of didn't work for us. So
Okay.
in AWS, I guess only network load balancer was allowing us to attach an elastic IP to it.
Hmm.
At least back then, this is 3 years ago.
Hmm.
Not sure of the state right now, but then we had to kind of move the architecture to use NLBs and then do all the L7 based routing,
Hmm.
inside the system. We were not even using Kubernetes, by the way. We were using Nomad. Uh,
Okay.
but yeah, I mean, whatever routing was happening at ALB, we had to kind of shift it to an Nginx, which was running inside. And again, there was another use case at Browser Stack. So they also needed static IPs for these APIs.
Hmm.
So we had load balancers, but we also had two public EC2 VMs running HA proxy
Hmm.
with static IP, and we had like enterprise dot something something dot
Hmm.
and that kind of worked as a load balancer for us. So I guess cases where whitelisting is required, this becomes a
Hmm.
necessity, and ELBs typically don't really help out.
I'm searching on the net right now. So Kubernetes load balancer static IP. Let's just see what I get. IP. I think it is possible. What I'm seeing on the answers there, that it is possible, right? So I believe as long as your provider can give you, you can fix it. So load balancer have a support to of support that IP, and that's all works. So I see that it is possible, and you can do that. Should be okay. At least now it is okay. If it was not early, but it is okay for now. Correct. Then we have a service type of external name. The idea here is we'll have a service, and then that service we would give a DNS name to it. I mean, not a DNS name. We'll give, yeah. So basically, think about you are migrating from on basically your own. Okay, think about you have been managing the cluster, or you have been running your all the workload on the cloud, including a database. And for database, you have used the managed service, for example, right? And then now what we are doing is we are currently migrating all of our stateless application on cloud. But then how do we access our database which is running outside? So for that use case, we can use this service of type external name. The idea is that we would give a we'll create a service of type external name, which can be, let's say, my service or my database service. And in that service, we would use the TNS name of our managed database offering. And that is when we would use this particular service type. Make sense?
Yeah, it does, but honestly, I've never used this kind of service ever. I just know that it exists. Never had
Hmm.
to use it.
If you
Yeah, I even didn't know that it exists until I was reading this.
okay,
So
good, good. So no, I have used it once with the managed database. No, I've used it actually a couple of times. So we had this managed. So we can either choose to give it at the at the front end level itself that okay, talk to this particular thing, or you can use this. So both works, but the benefit is only that once you migrate a database to to Kubernetes, right, your service name remains the same. Correct.
Yeah.
That is the benefit of it. Correct. Yeah. Okay, for the headless service, when you want to talk to the pods directly, basically when you want to connect to the pods um directly rather than going via service layer, we can use this headless service. So primarily running all the stateful sets, we use this headless service. So I think we would have use case of this later coming on, but I hope this makes sense to everybody. What is it?
Yeah.
Yeah. Okay, the next thing is protocol supported. So basically, we can use for UDP, TCP, or ITC or SCTP, right? So we can use uh, those kind of ports there. But I think this point was mentioning about yeah, this is also supported there. Yeah, this is fine. Um, what else? Yeah. Then talked about endpoints. So one thing I learned from this book is that the endpoints objects gets created as soon as we create a service, right? So what are the endpoints? Are nothing but your pod's IP address. These are the actual endpoint where you'll go and connect to it. But there is something called as endpoints, and then that would list all the endpoint what we have one by one. So our service, when it gets created, another object called endpoints get created, and in these endpoints we will connect all the pods which have a similar label. Correct. That is how this endpoints are there.
yeah, it
And yeah,
was new to me too. I was kind of surprised because as we work with it, it works as magic, but then there's like things behind it like this that enable this. I don't know this.
yeah, correct, correct. Yes, that's a very good point. I mean, yeah, that's why kind of these books would help us uncover some of these things, right? Um, Yeah, so I have used, I know that endpoints are there, but I was not aware that the endpoints object also is there. So that is, I mean, I used endpoint. I'm not sure why not the endpoints command earlier, but that's okay. It's just that nothing but a kind of an array of multiple pods IP address what we have there.
This can be a
Yeah,
good
so
interview question.
yeah, of course,
That
definitely.
will be tricky one.
Yeah.
Yeah, it is. It is. So that was the point which is mentioned here. And then, of course, the main point here is that that these endpoints should become the endpoint actually only when the application running inside the pods is in the ready state. Correct. So it should not happen that one of the pod is running, but inside the pod the application has died. Correct. Then uh, it would not be good, right? So we should do some kind of a health check before we add the pod's IP to the endpoints. So for that purpose, we can do two ways. That's what was mentioned here. One is you can check from the Kubernetes itself, or we can use the probes, right? So somehow we need to figure out um, that our application is healthy. Then only you should be adding in the endpoints. So that is why it's a must to have a readiness probes in your application pod when you're creating. Otherwise, it can become challenging, right? Uh, that was the point was mentioned here. And then we have this endpoint slices resource, which basically like the point is that if we have lots of services or lots of endpoints if we have, right, then managing them can become challenging and can be expensive. So we would just break them into different endpoint slices, and that way we can update them, manage them much more simpler way. So the default is 100 endpoints per endpoint slice. So that's the thing which was mentioned there. Rather than having one endpoint managing multiple or thousands of endpoints, we can break them, and that would simplify this. So that was the point mentioned here. Correct. Okay. So next is how do we implement this, right? The point is simple that if we hit the service IP address, when how would the traffic would go to the underlying pods, right? And as these pods come and go, how we would manage that connections and so on. And for that purpose, we need to somehow say that if the traffic is coming on this particular service IP, send it to these endpoints. And that was what we discussed here, that how we would do that. Correct. So there is the kube proxy which does that for us. uh, but we can configure kube proxy in different modes to connect the underlying pods IP what we have here. So when we hit the service IP, how would the traffic would go from service IP to the pods? That is what mention. That is what is being kind of put up here. So the different modes are there: IP table modes, IPVS mode, and the user space mode. So user space mode is no longer applicable because kind of deprecate, I believe. So we can look at either the IP tables mode or at the IPVS mode. Correct. So that is are the two things are there. Now, as you know that, right? Or I'm not sure that you're aware, IP tables. What we mentioned here is whatever the listing or whatever the firewall configuration you would do, right? To traverse it, you will require you traverse everything, correct? And if you write also to write everything again and again. So that was challenge with IP tables because sometimes if you have lots of services, updating the IP tables can become challenging. So that is when we have more than 10,000 services in a given cluster, it is recommended that we use the mode of IPVS than the IP tables mode. Correct. Um, Now, as you would know, IP tables, it would kind of work in a chain that you connect one point to the next point and so on. And that is what been mentioned here, that we have these different chains available, and through this chain, our kind of connection would be made eventually. Correct. The first chain, what is mentioned here, is all the services. So there's one chain which kind of listing all the services what we have. From that chain, we go to the respective service. So, for example, in this case, we are referring this particular chain here. So we are saying that if you hit this particular chain, you would go to these. You can go to these different pods here. So you can see here, this is a respective name given to the chain, whatever that object target is being given here. This is your respective pod reference name, what you can say here. And then what has been given here is a priority. Correct. So when the traffic hit from a service layer to a given pod, what is the probability I'm going to give it to you? And then we have here for the given pod, what is the respective IP address? Correct. So we hit the service on service, whatever the Nginx service port or Nginx service, it would then can go to any of the pod, and depending on the pod, it would eventually hit the respective pod's IP address here. That is how the flow is being defined here. Hope this is clear to everyone.
Yeah.
Yeah. Okay.
Yes.
Now, hmm, there were two terms being used here: DNet and SNet. Correct. So, have you heard about these terms, DNet and SNet? And if yes, then what does they mean?
Basically, DNAT happens when a packet leaves a node uh, where the destination IP address is basically replaced, or the packet is modified and the destination IP is kind of changed to one of the
Mm.
pod IPs from this list. And source NAT would be when the packet is on the backwards journey on the same node, right? So
Correct.
I think there's something called as contract in Linux, which keeps a track of which packets were
Yeah.
kind of modified.
Correct. Correct.
And
That's
when
going to
that
be.
particular packet comes back, there's a source network address translation, so that the source IP is kind of changed. So it goes back to the pod which
Correct.
generated.
So it is required because we are going to connect from the public IP to the private IP of the pod, right? So we require DNetting, destination netting, right? So that is what the DNet means, that you hit a public IP to access or the node port. From there, will come to the service layer and service to the pods, right? But these pods have a private IP, so we need to do a denetting here, that how we will map that this traffic has come from here, and that is what was mentioning about this contract, right? This is the one, right? Connection tracking, correct? So as you can see here, this is the packet coming from the outside. You can see here, so this is the source IP, which is 192.168.0.9, and destination IP is 10.96.0.14. Correct. Now, from here, uh, as just a minute. So basically, we'll do a DNAT here, and then we would source IP is there, and destination is so connection tracking table entry that tracks the connection from pod IP this to the service of uh, this one. Yeah. So as you can see here, what is mapping here is that this is your pod's IP through which you are doing the connection to what, to this particular service. Now, as we know that this service is a virtual IP only, right? It should eventually go to the pod's IP. And that is what denetting has been done here. That when you hit from this pod to this service, it would eventually go to this particular pod IP address. That is what denetting is. So you are replacing the source IP to the eventual pod IP to it connect to. Correct? That is called denetting. Hope that makes sense. And then in kernel, we will map, or we will have this kind of cache. So next time, whenever the traffic comes, we know that how to map. Correct? Hope this is clear. Um, Then similarly is the masquerading, which is nothing but I think SNet part, right? Which is there. So you may have noticed that we have claused this. These rules are in place of the packets that arrive at a node from the outside cluster. To do such packet properly, the service fabric need to masquerade source NAT. The packet when forwarding them to another node. This is being used. So. So the source net, yeah. So basically, the same thing is that other than we're discussing about external to internal to external, this way the same thing is saying that when the traffic is going between the nodes, right, from node one to node other node spots, that is where we would be using the masquerading here. That is what at least I understood. If you have more points, please mention that. Um, then what was mentioned is next point, performance concern, right? So of course, what I was mentioning earlier, right? It suffers from the ON complexity. So if you have lots of services running inside a cluster, it can become challenging to you, and that is why I think the limit is 10,000. So if you are having more than 10,000 requests in the entire cluster, better to go with the IPVS mode. In this particular mode, so there is hash table is being used rather than it is being used as the linear thing, right? So with the hash table, things would be much more faster, and that is how IPVS would help you getting your eventual destination pods much more faster way. So that is what is being mentioned here. So IPVS also work at the kernel level, while the IP tables work in the user space mode. Of course, with the help of kernel, it does. But IP tables as a software runs in the user space mode. But if you are going with the IPVS, it would be in the kernel, and that would be much more faster. And of course, the algorithm is also better as compared to the IP tables one. So that's how we should use IPVS only if we are going more than 10,000 services within our cluster. Right. So now they have mentioned that how we can implement the IPVS. So for that purpose, it is mentioned that I'm not too expert on that, but the idea what they are saying is on a given node on which no, not a node. So first, we will add the IP address of the cluster IP. Yeah. So what they're saying is we are going to add whatever the cluster IPs we have as the other, you can say, alias or other interfaces on our node. So for example, here you can see on the given node, if you look at, there are multiple IP addresses have been given here, and these IP addresses would be given to your different services. And for a given service, we would then have the different uh, endpoints like the pods IP connected to it. So then what they are saying is we'll have these dummy interfaces, and then with these dummy interfaces, we are going to connect to the underlying endpoint, which is the pods IP address. So that is how the IPVS would manage um, the the cluster IPs. And again, for the load balancer and for the node port part, you can see again there's another layer here. You have the node port here. On the node port, we'll have a service to the pods here, and that is how it is able to manage the the different. So what you see here, first of all, is we have one load balance. Sorry, the nodes IP and the node port number, and you can see here it has been running on the local host as well, at the same time running on other interface IP address as well. So that is how it has been configured. Now, what is this IP address? I just checked that. That's your cluster IP, right? So you have the nodes IP on the node port, then you have your cluster IP on port 80, then you have your um, local interface on the node port, and then another interface if you have on the service on the system, then for that particular node and the port number. And you can see all the endpoints are same. So you hit any one of these things, you would eventually reach the underlying pods IP only. They are all same in all across. So this is how it can manage the things. So yeah, so this is they are doing with the help of IPVS list, something like that is there. That is how they are managing it. Then they are supporting. They are saying that okay, we can run the kube. We can run our system without kube proxy. So first of all, what was the point? They have mentioned that the kube proxy was the name given for from the earlier days when actually it was behaving as a proxy. But from there, we moved to the implementation of IP tables based and IPVS mode. So even the kube proxy name is not actually the should be given per se, right? But anyway, the name has been continued here. But then now we have this APBF based networking, which can actually be much more faster than proxy based things. Correct? That is what we mentioned here. So Calico and Cilium both support eBBF. But while this book is being written, it was not very mature. But now we know that we can run our cluster without the proxy, and Cilium and Calico both can do it for us. So we can ignore proxy, and we can make multiple like multi-x performance benefit if I use the Cilium or Calico, which is EPBF based. Right? Any points here?
No, I guess we are good.
Okay, hope you guys are following. Okay, fine. Okay, Then we discussed about then let's discuss about how do we figure out the service discovery, like how do we figure out the endpoints. Like I don't want to kind of connect the pods directly, I'll connect by the service layer, right? So how would you figure out the names there, right? So for that purpose we have the different way of doing things. One is the DNS way. So as you know that when we configure the Kubernetes cluster, they can create, we can install core DNS or some of the similar software, and this core DNS can map the service IP to the pods. So the default format is here: the service name dot namespace dot svc dot cluster dot local. Right, this is the default way of doing things, and by default, this is the how service name is being given. And then, so whenever we do a service creation, the mapping of the service name along with these dots, what we see here, get mapped to the DNS, and that is how we can get our pods to get the IP address of the services. So whenever a pods get created on every pod, this particular file is modified, and then we have our search domain mentioned here, along with the IP address of the DNS. This entry, what you are seeing, is from every pod. So every pod would kind of contain the IP address of the DNS server, and whenever we access our pod name, by default this suffix would be added. So for example, if I say my pod name is xyz, then so no pod name, sorry, my service name is xyz, then in that case the complete service name becomes xyz.default.sv.local, because that is the default search domain what we have there, right? And then if not, then we'll go to the next and so on. Makes sense, right? So like here we are doing an NS lookup of Nginx. So by default, we'll get Nginx dot default dot service dot sort local. But if you specify dot default, then you would specify from the second dot here, like this one. So we'll start from here like that, and that is how it is going to go through. That's what they kind of explained here. Like when we are hitting the google.com, it will try to kind of map with different domains, but eventually it would be served from the google.com only, rather than, because you'll not find anything like this, correct? Unless you specify google.com dot, which means it's kind of finished. It's the end point. It's the last point to search. Like as you know that in the fully qualified domain name, right? We start from the backwards, right? And if we see the dot at the end, we see it's the root only, correct? Which means I have to look at only this. I'll not bother about adding the search domain to it. That's what they said, that if you use dot at the end, it would be the single pass will get the mapping there. The other way is the get the service routing by the API way. This was like an internal, which is I was not aware earlier. So it is like that you do service discovery by the API calls. That's what I understood here. Or the other way of doing it by the environment variables. But the problem with environment variables is you will have the information about the pods or the service which created earlier, not later point of time. So generally, we are going to only use the DNS way, which was mentioned earlier, core DNS way. And to make the performance better, we can install DNS cache as an add-on, which can run on every node, and that can make our life easier. So DNS cache can serve the request from the cache, as the name suggests, be much more faster. Or this thing was surprised to me that there is a something called as cluster proportional autoscaler, which I had not heard about at all earlier. With this particular autoscaler, what I'm getting is that based on the cluster node size, we can scale the core DNS. So that is a very good point, that rather than focusing on only on HP and others, you can configure this proportional autoscaler, which can help us scale the core DNS, like in this case, based on the number of a replica per node ratio, correct, or per core ratio, which is very good. So basically, if you know that our we're getting more replicas and we have less number of nodes, or whatever the count is there, based on that we can create more core DNS endpoints. So that way, things can be much more faster in the DNS perspective. It's a very good point. Um, okay, so I think with that we have moved to the kind of come to the ingress part, which I think I'm still yet to read, but though we can cover, but I think let's try to cover the ingress establishment in the next chapter, next session.
Yep.
Anything else we want to discuss here?
No, I guess we are good for today. Let's keep ingress for the next session.
Yeah. Okay, so we'll do ingress and the service mesh in the next session. And what next? Let's see how big it is. I guess decent. And what else after that? Data plane proxy. Yeah, I think we can do that, and then if time permits, we'll start with the secret management. But that's okay. I think we can cover those two things in the next session and then continue forward. Yeah.
Yep.
Okay.
Sounds good. Thank
Fine.
you.
Anybody else want to lead the next session? Any of you? We are three of us only here.
I think you're doing a very good job, so I wouldn't. I wouldn't want to try.
Smart, smart played, smartly played. Yeah. That's a good answer.
That's
No,
true.
but I can take it up. I mean, if you're not available or something.
No, no, I'm available. That's fine. I think let's take the secret management. You can take the next one. I'll finish this,
Okay.
and you can take the secret management.
Sure thing.
Right? Yeah.
Sure thing.
Sounds good. Okay, then. See you guys in the next session. Yeah.
Thank
Okay,
you.
man.
Yes.
Bye.